So last time we looked at the price elasticity of demand. Now we need a way to measure that. Remember that the price elasticity of demand refers to a change in the quantity demanded that results from a change in price. And we'll first look at the formula, and then we'll go on and talk about some of the benefits of using that particular one. First, let's think about where this price elasticity of demand is really coming from. And in order to do that, what we need is to think about the demand curve itself. And remember, that's a relationship between the quantity and the price. And so we have some demand curve. And the question that we're really interested in is what happens as the price changes, right? So we have 2 points on the demand curve, and we think about the price dropping. So maybe this is the model for soda, and it would be cases sold per week. And we need not only do we need to think about the product, we need the size here. So in this case, we're going to talk about cases. And then we also need to think about the time frame. And then in terms of a price, let's imagine that the price up here is $14, and this is $11.50. Now we know from the law of demand that as the price falls, what should we expect? We should expect demand to increase. And so how big is that demand increase from this change in price? And what we could see is, maybe this goes from, say, 80 to 100. But a different demand curve would actually show us a different change. And so what would that look like? Imagine a demand curve that was, say, a little bit flatter, something that looks like this, that sort of second demand curve. Well, as the price drops, what we see is that change in the quantity demanded is actually bigger. Maybe that's 120. And the price elasticity of demand is really a way to help us understand how big this quantity change is. Is it relatively small, from, say, 80 to 100, or is it bigger, from 80 to 120? And we can look at then the formula for the elasticity of demand. We'll abbreviate this. That's a mouthful. And so the elasticity of demand, we're going to start with an absolute value. And then it's really the percentage change in quantity divided by the percentage change in price. And we're going to leave it as the absolute value. Now, we calculate this in a very specific way. So the percentage change in quantity is really the ending quantity minus the starting quantity. And then we divide this by the midpoint, right? Halfway between those 2 points. So it's the sum of the two quantities divided by 2. Now there's a lot of different operations here. There's 2 divisions, a subtraction, and an addition here. So be very careful as we think about calculating this. If you're going to plug it into a calculator, you really need to make sure you watch out for those different operations. And then we're going to do something very similar. So the percentage change in price is really the ending price minus the starting price, and then again using the midpoint of the 2 of those. So it's the sum divided by 2. Again, we want to make sure we do this operation first, and then calculate the percentage, and then again, all of this is in absolute value. So now that we have the formula, we could actually look at doing the calculation using, say, that demand curve that we started with, where we have a price decrease of $2.50 going from 14 to 11.50, and we have an increase in quantity going from 80 to 100. So what would this formula then look like? Well, the change in quantity, we have 180, so we need to start with 100 minus 80, all divided by the midpoint of these 2. And so what we see here is then we take this thing, divide it by 2, And now that's the change in quantity, so that's the numerator. And then we need the denominator here, and so that's the change in prices. And you'll notice here it's 1150 minus 14 all over 1150 plus 14, and then we have to divide that by 2. And then all of this is in absolute value. And you'll notice something here, right? The numerator here, this thing's going to be positive because the quantity increased. The denominator is going to be negative because the price dropped. And that's really, the absolute value is going to be important for that. Now, the result of this whole calculation, in terms of the numerator here, is 0.4. And then the denominator is minus 0.196. And if we take this and actually do it out, it's 2.04. This is the price elasticity of demand given that original demand curve. Now, what does this number actually tell us? Right? It's important to kind of recognize what's going on here, that these are percentage changes in quantity and percentage change in price. And so here we're talking about this as 2.04. One thing I always like to do when I consider something that was originally a fraction is consider, well, what if it looked like this? It was 2.04 divided by 1. Well, now we can talk about this and interpret it using where we started. So the percentage change in price is, say, 1 or 1%. The percentage change in quantity is 2 or 2.04%. And so from this, we can now interpret the price elasticity of demand as if the price decreases by 1%, the quantity demanded will increase by 2.04%. Now, it's important that because we took the absolute value, this whole thing is positive, but price and quantity are always moving in opposite directions, at least for the goods that we're going to talk about right now. So now that we have the formula down, after this, we should take a look at, well, why do we do things the way that we do? Right? Why are we using percentages? Why are we using the midpoint? Why are we taking absolute value? And what we'll do is we'll look at the underlying idea behind the price elasticity of demand and come up with some benefits that we get from doing things this way.